going to make a frequency distribution table from the data that we've gathered and solve for the mean, median, mode, skewness, and kurtosis.
Good day everyone, I'm Marcus Chanel Adelfit and I'm the one who will discuss the first 4 steps of making the FDD. So these are the scores in MC Math 01 in Brilliant. And before we proceed on the FDD, we should go to the stem and leaf display procedure. So the purpose of this table is to arrange the scores in order. Since the scores are written in 2-digit number, we'll go to tens. And as you can see, the smallest number written here is 65. So we will write first 6, next 7, 8, and 9. After that, we're going to determine the corresponding units of the tens. Since the first score is 94, we're right here 4. Next is 73, 65. So now, we'll arrange the units in order. Next is, we'll count how many units, how many scores are there. So now, we'll add these numbers to determine the 23, 16, 5, and 2. 3 plus 6, 9. Plus 5, 14, plus 2, 6, carry 1. So 1 plus 2, 3, plus 1, 4. So the total numbers of the score is 46. Since we are done on the stem and leaf display procedure, we will go on solving the range, class interval, and class size. So this is the formula on getting the range. HS minus LS. So the highest score is 94. Minus the lowest score is 65. Range is 29. This is the formula of the size. 1 plus 3.322 log n. So equals 1 plus 3.322 log n. Since our n is 46, we'll write 46 equals or 7. So now we're going to the class interval, R over K. So our R is 29 and our K is 7. 4.14. Or 5.
Good day everyone, my name is Jerlyn Tumay and I am assigned to do the FDT or the frequency distribution table. Since we already have the steps, which is the stem and leaf display, the range, the class size, and the class interval, so let's have now a frequency distribution table. So our class interval is 5. Let's write the lowest score, which is 65, and add 5. So since our class size is 7, so we have here a 7 column. End up with 99. And now let's proceed to the frequency, which is the score that is only belong to 65 to 69. So 65 to 69, we have 2. And then 70 to 74, 70 to 74, 1, 2, 3, 4, 5, 6, 7. And then 75 to 79, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 80 to 84, 15. Next, 85 to 89, 1, 2, 3, 4, 5, 6, 7, 8. 90 to 94, we have 5. And 95 to 99, since none, let's put it. And the total of the frequency is 46. And now let's have the x, or the midpoint. So the midpoint of the 65 and 69. So the midpoint of 65 and 69 is 67. Let's proceed to the fx. So how to find the fx? Let's multiply the frequency and the midpoint. So 2 times 67 is 130. So let's move to cumulative frequency. So we have two kinds of cumulative frequency, which is the less than and the greater than. So let's have first the less than. So 2 and so let's move to class boundary. We have the lower class boundary and the upper class boundary. When we say the lower class boundary is we're going to minus 0.5, and then the upper class boundary is we're going to plus 0.5. Okay. 65 minus 0.5. X squared. So let's multiply the x by itself. So our first x is 7. So let's proceed to f x squared. So let's times or multiply the f to our x squared.
Good morning. I am Raymond Mark de la Cruz, and I am going to solve for the mean, median, and mode. So this is the formula of getting the mean. So fx. So summation of fx is 3,717. Divided by the total scores 46. 80.8. Our mean is 80.8. Now, this is the formula of getting the median. Before we get the median, first let's determine the median class, which is the total of n is 46. 46 divided by 2 is 23. So Now let's find the 23 which it belongs in the FDT. So since 23 is belong here in the 33, so this is the median class. Now let's get the lower median boundary. So the lower median boundary is 79.5. So now let's get the cumulative frequency before. So the cumulative frequency before is 18. So let's write here 18 and the frequency of the median class is 15. So let's write here 15 and the class interval is 5. So now let's solve. This is our median. Now let's get the mode. So this is the formula of the mode. So before that, let's find the model class. Determining the model class, first let's find in the FDT the highest frequency. So this is the model class. So let's find the lower class boundary in the model class, which is 79.5. Since we have here the highest frequency, which is 15, let's subtract it into before the highest frequency, which is 9. So 15 minus 9. And in finding the delta 2, so the frequency of the model class is 15 minus the frequency of the model class after is 8. Since our delta 1 is 6, so let's write here 6 and divided by the delta 1, which is 6, plus the delta 2 is 7 times the class interval. This is the mode.
Good day everyone, I'm Irene Pidong and now let's find the skewness. So the formula of skewness is skewness is equal to 3 times the quantity of the mean minus median over the standard deviation. Since we already have the mean and median, now let's get the standard deviation. So standard deviation formula is square root of n summation of fx squared minus the summation of fx squared over n minus 1. So square root of the value of n is equals to 46. Then summation of fx squared is equals to 359 minus the summation of fx 3717 squared over n is 46. Then 46 minus 1 is equals to the square root of 46 times 302,359 minus 3717 squared is equals to over the 46. 46 minus 1 is equals to 45. Then 46 times 45 is equals to 2070. So divide this one or this two, that equals to 44.65. So the square root of 44.65 is equals to 6.68. So this is the standard deviation. Now let's go to the skewness. So skewness is equals to 3. Then the value of, or the mean is 80.80 minus the median 81.17. Then the standard deviation is 6.68. Is equals to 3 times, 80.80 minus 81.17 times 3 is equals to negative 1.11. Then copy the standard deviation, 6.68. So negative 1.11 divided by 6.68 is equals to negative 0.17. And it is negatively skewed. That's all.
Good day, I am Lee Margaret Shal and I am going to solve for the kurtosis. So kurtosis is the thickness or flatness of the curve. So it is denoted by QU. And the formula of the kurtosis is QD over PR. And in determining the QD or the quartile deviation, we have to obtain this formula. QD equals the third quartile minus the first quartile over 2. And in getting the percentile range or the PR is, we have to subtract the 90th percentile to the 10th percentile or the P90 minus P10. But before obtaining the value of the QD, let's have first get the value of Q3. In getting the value of Q3, we have first to get the class of measures of position of the Q3, which is En Q3 is equals to 3 over 4 times the N, which is 46. So 46 times 3 is 138 divided by 4. So the class of measures of positions of the third quartile is 4.5. Okay, so now that we get the class of measures of position of the third quartile, so we must follow the formula on getting the third quartile. So this is lower class boundary of the third quartile plus the class of measures of position of the third quartile minus the cumulative frequency before over the frequency of the third quartile times the class interval. So to determine the lower class boundary of the third quartile, we must find first the quartile class of the third quartile. So since our class of measures of position is 34.5, we should look at the cumulative frequency on the frequency distribution table. So as you can see that 34.5 belongs here in 41. So therefore our quartile class is this. So this is our third quartile class. And now, since we have the quartile class, we can now obtain this formula. So the lower class boundary of the third quartile is 84.5 plus our class of measures of position is 34.5 minus the cumulative frequency before the quartile class. So this is the cumulative frequency of our quartile class and before is 33. So therefore we should minus this on 33 over the frequency of the third quartile, which is 8. So over 8 times our class interval is 5. And now we can calculate the given. So 84.5 plus 34.5 minus 33 is equals to 1.5 over 8 times 5. So 84.5 plus 1.5 divided by 8 times 5 is equal to, so 1.5 divided by 8 times 5 is 0.94. So now our third quartile is 84.5 plus 0.94 is equal to 85.44. So this is now our third quartile. So we have now the value of our third quartile. So now that we get the value of the third quartile, so we can proceed in getting the value of the first quartile. But before that, we should get first the class of measures of position of the first quartile. So Kn Q1 is equals to 1 over 4 times 46. So 46 over 4. So our class of measures of position for the first quartile is 11.5. So 11.5 is our class of measures of position for the first quartile. So now, before proceeding to the next procedure is, let us look at our frequency distribution table on the cumulative frequency. So 11.5 belongs here in 18. So therefore, this is our quartile class of the first quartile. So now that we have the first quartile class, so the lower class boundary of the first quartile is 74.5. Plus, our class of measures of position is 11.5. 11.5 minus the cumulative frequency before the first quartile is 9. So minus 9 over the frequency of the first quartile is 9 over 9 times the class interval, which is 5. 11.5 minus 9 is 2.5 over 9 times 5. So 74.5 plus 2.5 divided by 9 times 5 is equals to 1.39. And our first quartile is 74.5 plus 1.39. So 74.5 plus 1.39 is 75.89. So this is now our first quartile. So since we have the value of the third quartile and the first quartile, we can now solve for the quartile deviation or the QD. So in getting the value of the quartile deviation or the QD, this is our formula. Q3 minus Q1 divided by 2. So the value of Q3 is 85.44. Minus the Q1 is 75.89. Over 2. So 85.44 minus 75.89 is equals to 9.55. So 9.55 divided by 2 is equals to 4.78. So this is our QD. So our quartile deviation is 4.78. So since that we have the QD, so we can now proceed on getting the percentile range. So before we get the value of the percentile range, we must obtain first on getting the value, or we should solve for the 90th percentile and the 10th percentile. So in getting the 90th percentile, we should first get the class of measures of position of the P90. So Pn P90 is equals to 90 over 100 times 46. 90 times 46 is equals to 4,140 over 100. So 4,140 divided by 100 is 41.4. So our TN P90 is 41.4. So this is now the class of measures of position of the 90th percentile. So looking back at the FTT, so this is the 90th percentile class. So in getting the 90th percentile, this is again our formula. So the lower class boundary of the 90th percentile is 89.5 plus our class of measures of position of the 90th percentile is 41.4 minus the cumulative frequency before the percentile class. So our percentile, the cumulative frequency of our percentile class is 46 and before, so 41. Over the frequency of the percentile class, which is 5 times our class interval is 5. So 89.5 plus 41.4 minus 41 is 0.4 over 5 times 5. So 89.5 plus 0.4 over 5 times 5 is 0.4. So 89.5 plus 0.4 is equals to 89.9. So 89.9 is the 90th percentile. So now that we have the value of the 90th percentile, we can now proceed in getting the value of the 10th percentile. But before that, we should get first the class of measures of position of the 10th percentile, which is 10 over 100 times 46 is equals to 460 over 100, 4.6. So this is our class of measures of position for the 10th percentile. Since we have the class of measures of position of the 10th percentile, we are going to look on the cumulative frequency of the frequency distribution table on where does the 10th percentile belong and where class does it belong. So this is the 10th percentile class, this column. So now, since we have the percentile class of the 10th percentile, we can now obtain this formula. So P10 is equals to the lower class boundary of the P10 is 69.5 plus the class of measures of position of the 10th percentile is 4.6 minus the cumulative frequency before, or the cumulative frequency before the percentile class. So this is the percentile class, the cumulative frequency is 9. So before 9 is 2. Over the frequency of the 10th percentile. The frequency of the 10th percentile is 7. 7 times the class interval, which is 5. 69.5 plus 4.6 minus 2 is 2.6. 2.6 over 7 times 5. 69.5. Then 2.6 divided by 7 times 5 is 1.86. So 69.5 plus 1.86 is equals to 71.36. So 71.36 is now our 10th percentile. So now that we have the value of the 90th percentile, which is 89.9, and the value of our 10th percentile, which is 71.36, we can now proceed on getting the value of the percentile range. The formula of the percentile range is P90 minus P10. So our P90 is 89.9 minus our P10 is 71.36. So 89.9 minus 71.36 is equals to 18.54. So our PR or our percentile range is 18.54. So now that we have the QD which is 4.78 and our PR is 18.54, we can now proceed on getting or on solving for the value of the kurtosis for our KU. So the formula of kurtosis is KU is equal to QD over PR. So the value of our QD is 4.78 over our PR is 18.54. So 4.78 divided by 18.54 is equals to 0.257. So our KU is 0.257. So our KU is 0.257. So when the value of KU is equal to 0.263, this is a normal curve and what we call the mesocortic. Then if it is greater than 0.263, this is a flat curve or the platycortic. Since it is 0.257 and less than 0.263, so this is a thin curve or what we call the leptocortic. Leptocortic. So the curve is that would be all for today. Thank you for watching and we hope you've learned something from our discussion. Thank you.